Artificial intelligence is slowly appearing in every aspect of our modern lives. It's in our smartphones, our central heating, on our sideboards, and in our cars. But what about artificial general intelligence? That is the real quest. The aim to build an agent, an algorithm that can learn to solve any problem from scratch without being taught how. Welcome to DeepMind, the podcast. I'm Hannah Fry. I'm a mathematician who has worked with algorithms for almost a decade. In this series of podcasts, we're following the fast-moving story of artificial intelligence. For the past 12 months, we've been tracking the latest work of scientists, researchers and engineers at DeepMind in London. We're looking at how they're approaching the science of AI and some of the tricky decisions the whole field is wrestling with at the moment. So whether you want to know more about where technology is headed or want to be inspired on your own AI journey, then you've come to the right place. Now, in the last episode, we were talking about how pitting artificial intelligence against world-class players in the game of chess and the game of Go is about much more than just showing off what a computer can do. Human players can learn from how the AI plays and improve their own play as a result. And there's also a bigger picture. The world of games provides the perfect mini-universe to try out everything we want our artificial intelligence to do. But intelligence is much more than just championing raw logic. Intelligence requires other skills, like the ability to collaborate. I want to introduce research scientist Max Jederberg. Max and his colleagues are trying to work out how to train agents to work together as a team.
So imagine, say, a few decades in the future, we have all these AI systems out in the world doing different things, but they maybe have never seen each other before. There's thousands of these things, hundreds of thousands. Each have their own objectives, but somehow they have to cooperate and compete in a sensible way, and in a very ad hoc way, in a way that they've never seen each other before.
Humans are really good at this, when we want to be, anyway. Even when we haven't encountered another person before, we still know how to understand their intentions and how to interact with them. Our agents of the future need to be able to do the same thing with each other.
We already have things like Google Home and these sort of smart devices out there. We'll probably have more and more of those, and you can imagine them having to interact and work with each other, and one device may not have ever seen another device before, but they still somehow have to interact and get things done for you.
Are we talking about like your Google Home and your dishwasher here? This kind of stuff?
Yeah, potentially. You know, your dishwasher might want to actually go on its cleaning cycle, but Google Home wants it to, clean all the dishes. And so what's best for you as a person? I don't know.
And who gets to decide?
Who gets to decide?
Who rules supreme, your dishwasher or your Google Assistant?
Yeah, I don't know.
There's an important distinction here. If you've got a smart light bulb that you can program to come on at 6 o'clock in the evening, that is an algorithm. If you've got one that can learn your preferences, that can understand when you like the lights to be dimmed, what kind of mood lighting you like when you're reading, that is AI. But as we switch away from building things that do rigid, pre-decided tasks, we're asking our technology to read the situation and react to what's going on around it. And in the long term, that's going to require collaboration. So in the spirit of trying things out in a toy universe, the team at DeepMind have been trying to find inspiration in another kind of game, one taken straight from the school playground. This is Capture the Flag. You know the deal. The first team to steal the flag of their opponent and bring it back to their own base wins. If you get tagged by the opposition, then you're out of the game. Oh, come on, don't cry. Max dropped whole populations of AI agents into a digital version of the game.
This is an on-screen version. You just see your first-person point of view. So you have to sort of look around and move through this 3D world from your own first-person perspective, but interact with these other things which see their own first-person perspective. So here there's no centralized entity or being that can see everything. No army commander. Every player acts independently. They only see their own observation. And the way we train these things, we actually train whole populations of teammates, let's say 30 agents in parallel, and they're all playing with and against each other.
Rather than just creating a single agent, Max and his team build an entire classroom of them, 30 in total. And for each round of the game, he randomly selects a few of the agents from the class to play together on a team. By doing this thousands and thousands of times, each agent will learn from their own experience. But because they're playing with each other too, with their classmates, as it were, they have to learn to interact with someone who's different from themselves.
The problem is when we start, they're actually just all very random.
Yeah.
They're just bouncing about the place without a clue. And then one of them will discover something and will start actually, let's say, taking control of the flag and actually scoring points. And at that point, there's evolutionary pressure on this population.
And here's the clever bit. Max and his team aren't just letting the agents in the classroom play on and on forever. They're also using something called a genetic algorithm, a way to make sure the whole culture of the population of agents evolves.
So that actually some of the weaker ones will be removed from this population.
So it's almost like you're making that population of 30 have children.
Yeah, absolutely.
You're sort of breeding them together.
Yeah.
The original classroom of agents breed together and have kids of their own. And as you go down the generations, the strongest traits survive.
But unlike human children, when an agent has children in this setup, they inherit everything. They inherit the knowledge that's been gained from their parent.
But you're mixing up their characteristics as you go from one generation to the next.
Yeah, so this agent has to learn to play a 5-minute game of Capture the Flag, which is really, you play 5 minutes, you do thousands of actions, and you just get a win or a loss on whether you won or lost the game. And somehow we have to learn what to do with that. And so to help bridge that problem, we have this idea of internal rewards, where there are events in the game such as picking up a flag or dropping a flag, or your teammate tagging an opponent or an opponent tagging you, all these sort of things. And we allow the agents to individually evolve their own internal reward, which is the reward they assign to each one of these events.
So some agents are going to care a great deal about grabbing hold of the flag.
Exactly.
And other agents are going to care a lot about teammate tagging someone.
Yeah.
This kind of evolutionary group training means that they can assume different roles, producing better results for stealing a flag. And with a bit of practice, after a few thousand rounds, say, teams of agents become really rather good at this game.
They absolutely smash it. And the great thing about training an agent in this manner is that they're robust. Yes, they can play themselves, but they can play other agents that have been trained in completely different regimes. They can also play these in-game bots, which are sort of these hard-coded bots that ship with the game. But most interestingly, they can also play with people. So you can drop people into these games and have, an AI teammate or AI opponents.
What is it actually like to play with an agent then? Does it feel like they are guessing what you're going to do as well as doing their own thing?
It feels less like they're guessing what you're doing and more like they completely ignore you and they're very ruthless. Humans pay a lot of attention to other humans. Even in game scenarios, like humans will fixate on the other players of the game. But these agents have been trained completely unbiased without these sort of human biases. Your opponent will run right past you and not even try and tag you because they're so fixated on actually getting the flag as quickly as possible because that's what's going to maximize their number of flag captures and win them the game. Things that really annoying human players would do.
There's a kind of magic going on here. Initially, researchers are working on these agents, trying to see a way through the muddle. Then there is that breakthrough moment when the agent gets it, when they start to behave like you think they should. Let me tease you with Karai Cavocciolo, Director of Research at DeepMind.
I remember training agents in the early days. The first time, actually, those agents started behaving like, okay, it's an environment, it's trying to navigate and it's trying to avoid certain obstacles and whatnot. The first time it starts doing that, it is nice. It is like, it's quite fun to see that because you know that it makes the decision for itself. I think knowing that you have created an algorithm that can take decisions, I think that aspect is quite enjoyable. That is very satisfactory.
It's worth remembering that these games aren't just a trivial pursuit for DeepMind. They've invested in this rigorous training for a reason. They want to see how an AI develops these kinds of skills for itself.
We spend a lot of time in this Capture the Flag work looking into the neural networks of these agents to try and understand what they care about and how they represent the game world. And what was really cool is that we found that the agents actually had a really, really rich representation of this game world without being told anything about the game world itself. These agents just look at the pixels of the screen, yet somehow they've clustered their, internal activations into things like, oh, I'm in my home base, I'm in the opponent base, I've got the flag and I can see my teammate ahead of me. I'm looking at the opponent flag carrier while my teammate is holding our flag. And you can even find individual neurons which just activate if, for example, your teammate is holding the flag.
You can totally understand how the agent is seeing the game as you go through.
I'm not sure about totally understand, but we're really getting an idea of what is being represented strongly and what isn't being represented strongly.
Max's agents are using something called neural networks. It's a type of machine learning algorithm that is loosely based on a simplified version of the human brain. Layers on layers of artificial neurons are connected together in a vast network and fire information between themselves. By looking inside an agent's electronic brain, Max can work out which micro-level connections are responsible for what macro-level behaviour. And this could be hugely beneficial as AI becomes more integrated in our everyday lives.
The hope is that well into the future, we can start actually having agents which can go out into the real world, interact with humans, with other agents.
Without fighting.
Without fighting, being sensible, not squabbling too much.
Unlike humans.
Yeah, exactly.
Games without frontiers, teamwork without tears. But there is a big leap between board games or simple games like Capture the Flag and the big bad world with all of its complexity and messiness. You'll remember David Silver, the man who brought us AlphaGo, the agent that defeated the world champion at the ancient board game of Go. Well, he's also involved in pushing DeepMind's AI into ever more perplexing environments.
In the context of games, I think there is a further challenge which is many people in the community are moving towards, which is to take the most challenging computer game, in this case it's the game of StarCraft, and many people in the AI community are viewing this as the next grand challenge. How can we actually devise agents which can play in this very rich environment, which has challenges which are not only different, but many times vaster than Go in other ways.
This is DeepMind, the podcast, an introduction to AI, one of the most fascinating fields in science today. Have you ever seen footage of those vast e-tournaments where an entire arena of dedicated fans excitedly watches on in support of highly skilled players sat on stage in their gaming chairs, armed only with a keyboard, a mouse and a computer screen? Well, chances are they are playing something like StarCraft II, created by the American video game developer Blizzard Entertainment. It is a monumentally tricky tactical game where you play as one of three races, the enigmatically named Zerg, Protoss, or Terrans. Each player has to mine resources, build an economy, and acquire increasingly sophisticated technology, all the time trying to defeat your alien opponents in a futuristic, rather bleak-looking landscape. Your field of view of the simulated game is limited by a moving camera that you have to operate, and so there's no way to see everything at once. Often you can't see your opponent at all. And it is played by tens of thousands of people, sometimes for hefty cash prizes. And the human players are staggeringly fast. The best in the world can manage up to 800 clicks in a minute. Feeling inadequate?
Definitely super cool that I can work on one thing that has been certainly a passion of mine in my teenage days.
Meet Oriol Vignals, a research scientist at DeepMind. He is an ex-pro StarCraft player and co-leads the StarCraft effort at DeepMind.
As you develop a new algorithm or a new idea, when you test it, you actually see it play better the game you like. So that's very rewarding and very visual, right? That you try something new and you really see, oh my God, it really understands how this unit works.
StarCraft is a serious business, so serious in fact that it has now been professionalised. And for Oriol, that proves it is a game that pushes human intelligence.
Humans found it interesting, so that means it's an interesting game that challenges intelligence and creativity in ways that we like, that we spend many hours playing.
So how good is the AI at the moment then? How well can it play StarCraft?
It's better than any AI anyone has ever built, and it obviously has learned from experience, not from someone knowing the game and encoding some set of rules. This is, one of the most complicated games we've ever tackled. It's challenging kind of our understanding and our algorithms quite a bit.
The DeepMind team decided to see how good their work in progress really was by inviting two of the world's best StarCraft II players to take on their own algorithm. So let me introduce DeepMind's AlphaStar, the first artificial intelligence to ever take on top professional players. It plays the full game of StarCraft II by using a deep neural network trained directly from raw game data by supervised learning and reinforcement learning. Your commentators are Dan Stemkowski, aka Artosis, and Kevin van der Kooi, aka Rotterdam.
Well, first of all, it's really awesome to be here together with you, Dan. We're both, I think, incredibly excited to see how this evening unfolds.
This is just so exciting that DeepMind is doing all this.
Taking on AlphaStar in this benchmarking match is German champion Dario Wunsch, better known as TLO. He's normally a Zerg player, but he's playing as Protoss for this match. Kevin and Dan are excited. Maybe even a tad overexcited.
I'm so incredibly excited.
Oh my God. This is the most excited I have personally ever been for an event.
I can't wait to really break down some PvP.
So this is AlphaStar. This is an AI that we don't know how good it is yet, but already we have some interesting things happening.
Now, I'm not entirely conversant with the StarCraft playbook lingo here, so I will just say that AlphaStar's stalkers are laying down some sharp moves.
Feels to me like so far these attacks have been very well planned by AlphaStar.
And they're relentless. It loves to attack.
And in a matter of minutes, it's all over.
Well, that is it. The GG is called. The good game here from TLO. And the first game from AlphaStar against a pro gamer goes to AlphaStar.
David Silver was there at ringside.
We have a team that's been working on this and ramping up our development over the last few months, and this represents a milestone where we actually for the first time saw an AI that was actually able to defeat a professional player.
Shall we have a quick word with our defeated challenger, TLO?
When I was practicing, most of the humans I played against played very standard StarCraft. I assumed after the first match I'll probably have a good idea how to play against this agent. I did not.
Next up, the main event. AlphaStar versus Poland's finest, Gregor Kominch, better known as Mana, one of the world's strongest professional StarCraft players.
Mana, I need to hear what you're thinking here because that looked scary.
Yeah, AlphaStar, he's not scared about the ramp. So if I would be playing against a human player right there, nobody's going up that ramp.
I should point out for those of you that play StarCraft that these matches are taking place under professional match conditions on a competitive ladder map and without any game restrictions. This version of AlphaStar could see the whole of the game map at any one time, but otherwise played in a comparable way to humans.
Our goal is not just to defeat these players. Our goal is to do it in the right way.
All right, 2 seconds, guys.
And the result, AlphaStar 5, Mana 0. I should tell you that Mana played a later version of the algorithm in the end and won. So all in all, 5-1. Now, to understand how an AI could learn to play StarCraft, Oriol Vignals put me to the test. A match to the end, mathematician versus machine. I've got a quite a funky looking mouse in front of me and a normal keyboard, and on the screen there is a very mean looking alien. He's sort of like an elephant meets well, he's got fists. I wouldn't want to meet him on a dark night.
No.
Is he my friend or not?
He is you. Like you're gonna be the commander of this particular race. So
I quickly found out that there is a lot to take in. StarCraft is perhaps not for beginners. You have your worker bees collecting resources for you.
No.
These little, I mean, they're almost like ant creatures,
right? So
running out and grabbing crystals.
Exactly.
And you need to try and work out how your actions will affect the game in future. This is not easy for humans to learn, let alone agents that have absolutely no context, no object recognition, and definitely no former StarCraft champion to hold their hand.
Look, this is the enemy.
Oh no!
It's gonna be pleasant. It just came to kind of find you and now see what you're doing, which is absolutely nothing so far. We have done nothing at all.
Part of the challenge of StarCraft is that there isn't an ideal strategy that wins every time. It's a bit like rock, paper, scissors in that way. The winning tactic will depend on how your opponent plays. But remember, you only have a very narrow field of vision. Outside of where your camera is pointing, your opponent could be up to anything.
Because you don't see the other player, you must decide, when am I gonna see it? Do I already know what is going on? And should I not go and scout what it's doing? But maybe if I do that, he knows that I know, and so on and so forth. So this kind of imperfect information aspect of StarCraft is extremely interesting as a player, and it's gonna be testing our agents to levels that we haven't seen in any other game. And then, of course, there's sort of details that have happened in the game that you must remember for a long time.
Advice I should have listened to more carefully, perhaps.
We're being attacked and we're probably gonna die.
Oh no!
So that's okay.
It lasts very long.
So I think this discovery phase, right, where you would now basically you would lose, you get a reward of -1, and you start again.
If I was an algorithm, I wouldn't be upset by losing. I would just reset and go again, each time armed with a little more knowledge. But to even be able to play StarCraft in the first place, to even be able to operate the controls, the AI had to master quite a few transferable skills.
You've noticed when you were playing that there were some movements that were resembling what it was like to maybe navigate the web or like operate your laptop, namely click, drag and drop, like select rectangles and moving the mouse, maybe combining mouse with keyboard and so on. And we tried exactly the same agent, the same architecture, absolutely everything the same way, the same code almost. And we changed the environment. Instead of saying, now here is a StarCraft, please play to win, we said, here is Paint, Microsoft Paint as an environment, interact with it, and I'll reward you if what you paint looks like a face. And it actually worked. So I think that's just learning these basic skills of point and click interfaces that apply in so many places.
The same agent that plays StarCraft can draw real faces in Microsoft Paint.
Right. And here, the point to be clarified is not the same agent that was trained to play StarCraft. It's the same algorithm that can train to play StarCraft, can also train to do Paint.
Put that same algorithm to work drawing celebrities in Paint, and it can capture all the main traits of the face, clicking and dragging the mouse to recreate shape and tone and hairstyle, much like a street artist would.
It's the same technique, but if you will, it's kind of a brain that is blank, and then this brain can learn to do this or that, and then we kind of by acting in the environment repeatedly and getting reward, the brain waits or it gets shaped to do this task or that task or that task. We are not yet at the point where the same brain does both like we do, but obviously that's one of the things we would be very interested in tackling next as well.
Because that's stepping towards artificial general intelligence, I guess.
Exactly, and that's what we do every day.
That is the ultimate goal. And it's a topic of conversation that's never far away, whoever in this building you find yourself talking to. Because the point of getting AI to play games like StarCraft or Go is to enhance our understanding of what intelligence actually is. Here's Raya Hadsell from the Deep Learning team.
We write programs, we run those programs, those experiments where we might train an agent to play a game, for instance, or to solve a puzzle in a simulated world, and then we look at the results of that. It really is trying to understand this puzzle of learning and representation, memory, control in terms of actions that a robot would take. There's so many complex parts to this big puzzle of what is an intelligent being, what is an intelligent agent.
But if you ask people what they think the future of AI looks like, it tends to be wrapped up in something a bit more physical, something that comes complete with moving arms and everything.
I think one natural challenge for AI, which many people are centering upon, would be to actually have an impact on the real world in the guise of robotics, to actually see a robot which is able to move, to grip, to manipulate, to even have locomotion in anything approaching not even what a human does, maybe even an animal. I think this would represent a major stride forwards.
More on that next time. If you would like to find out more about the themes in this episode, or explore the world of AI research beyond DeepMind, you'll find plenty of useful links in the show notes for each episode. And if there are stories or resources that you think other listeners would find helpful, then let us know. You can message us on Twitter or email the team at podcast@deepmind.com. You can also use that address to send us your questions or feedback on the series. But for now, let's nip out for a bit of air.